Good morning, good evening, good afternoon, wherever you are. Thank you for joining us to talk about community best practices for open science as part of the GWEX River Experiment or RivEx. I'm Cedric David. I'm a research scientist at NASA's Jet Propulsion Laboratory. Together with everybody on this list, and I have affiliation on one of the affiliations on one of the last slides. My co-leads for this activity are Augusto Perrong, Simon Guy, and Dai. So all of us have been fostering this activity for a little while, and I think today is the official kickoff of our seminar series or the experiment itself. So thanks so much for being here. I'll get started. We'll talk about briefly what the river experiment is about, and after that I'll dive into uh, my hope for best practices of open science within this community, and then we'll open it for questions, remarks, feedback. All right, so let's get started. The rivers are the dynamic core of Earth's surface waters. It's known to be the renewable freshwater lifelines, and but it's also a devastating cause of disaster. I have a couple of references here. One is a science paper from 2006 that argued that surface water was the most renewable, accessible, and hence sustainable source of fresh water on Earth. And then there's this other recent report from 2020 that uh, highlights floods as being the most devastating cause of disasters out of all natural disasters on Earth. So what we're dealing with for surface waters is very small storage, tiny storage, but huge and mighty flow. This is the duality that we're dealing with for surface waters on Earth. Um, Turns out rivers don't care if you're upstream or downstream, they just flow downstream. But if you happen to be upstream, it's good for you. You have first access to water. And if you're downstream, well, then you have access to what's left over. And that sometimes includes pollution, which can be a problem. The map on the left here shows all of the world's transboundary river basins. Those are river basins that cross political borders, and there are uh, lots of them. Everybody needs water. The United Nations declared safe access to fresh water for drinking and sanitation as a human right. That was in 2010. And it turns out the world's population has been growing quite rapidly, now over 8 billion people. 200 years ago, it was 1 billion people on this planet. And I think the population has doubled in a lifetime recently. So everybody needs access to water. Water crosses borders, and there is more and more of us on this planet. There are other challenges, particularly those related to the changing environment around us, increased flooding, increased flood exposure, as in this paper on the top left side. I have all the references at the bottom. The amount of water being made available for rivers to flow, also known as runoff, is changing with climate. We already talked about transboundary basins, but there are other urgent environmental and societal challenges related to river system science, river biodiversity, spreading coastal dead zones, changing deltas. A lot of reasons why it's important for many of us to spend some time thinking about the surface water systems. We recently celebrated the 50th anniversary of the completion of the International Hydrological Decade. That was a good excuse to revisit some of the basic knowledge that we have of rivers, things like total flow of water from land to oceans through rivers. This is the time series that you have on the top left in cubic kilometers per year as a function of time between 1980 and 2010. And at the bottom, this is one estimate out of a few for the variation of river water storage. So we're looking at fluxes and stores for the world's rivers. The table on the right-hand side starts with, well, we have two tables and they both align with their respective chart. They start with the International Hydrological Decade, the findings from 1974, and they get updated with time. And what you can see is that there has been some changes in the total stores and fluxes, but mostly new information on amplitude, and there is still some variability in the existing estimates. Only recently have we started measuring this, at least for the changes in stores, with satellites using the Surface Water and Ocean Topography mission. Um, so we have some estimates primarily from computer models. Fortunately, we also have access to incredible information that is made available to the science community by the Global Runoff Data Center. I saw Simon is online. Hi, Simon. Thank you or Simon. I heard that's how we say your name. Thank you for joining. And now going around the world, shaking hands, asking people for their data sets and sharing it with the rest of us is a very difficult task. And GRDC provides a tremendous service to our community. This is basically the only thing we know in situ for rivers around the world. It's notoriously difficult to access information, and it takes a lot of hard work and social work to make that happen. So we're incredibly thankful for the amount of information that GRDC provides to the rest of us. We also have observations from satellites. I have a snapshot that is very ESA and NASA centric here, the European Space Agency and the United States Space Agency. All of these missions see something of value for surface waters, whether it is water quantity like elevation or extent of water, or water quality like composition or temperature. Now, the vast majority of these satellites were not specifically designed to observe surface waters, but they see something of importance about it. That is perhaps with the sole exception of the SWAT mission on the top left. But the potential is tremendous to bring these together with computer models and in situ observations to help solve some of the challenges that I mentioned earlier. So how do we do this? This is a schematic diagram for how we do river modeling. It starts in the atmosphere, usually with the atmospheric model or reanalysis data set. That has things like precipitation and wind and specific humidity. Precipitation falls on the ground. That information is handed off to what's called a land surface model. It deals with the one-dimensional vertical interactions between the land and the atmosphere. Usually the land surface model is going to take something like 7 or 8 variables, including precip and wind and specific humidity, and turn precipitation into what infiltrates into the ground, what evaporates or transpirates back into the atmosphere, and what runs off on the ground or underground. And the runoff is what we feed into river routing models. There are several of them involved in our experiment here today. And then we can check those simulations with in situ observations. We use mapped hydrography to move the water downstream of river systems, and we check based on in situ and remote observations. That's basically the schematic diagram that we're dealing with. I mentioned that we have a number of river models, and river models, as naturally all computer models, are diverse. In the case of river models, we have diversity in the types of computational elements being used, whether we're dealing with grids, sometimes with subgrid representation, whether we're dealing with blue lines and polygon catchments. Models differ in the equations that are used, their complexity, and the types of processes that can be represented by them. Also with the potential inclusion or not of anthropogenic effects such as water pumping or reservoirs. And then there is also all the numerical complexity. Parallel computing on open source, programming language, data assimilation, uncertainty quantification, whether there is a coupling, an exchange of information in a one-way or two-way basis with land surface models or the oceans. Lots of diversity to deal with that together makes it pretty difficult to extract knowledge from all of that. And so that's what brings us here today. We've built under the tutelage of the Global Energy and Water Exchange Program, GWEX, particularly the GWEX Hydroclimatology Panel, GHP. So we are one of the cross-cutting projects of GWEX. Our goal here is to deal with three primary science questions. The first one is about the state of hydrological modeling capabilities. Where, when, and why do we do well or do poorly? And also, how do we propagate knowledge and uncertainty? Second question is about the hotspots of anthropogenic influence. Um, so again, reservoirs, dams, pumping, divergences of water, and how that can be accounted for in models. And the third question is how we can optimally ingest the increasing number of observations. I mentioned in situ and satellites, airborne observations if we have them, to allow for more accurate reproduction of real surface water stores and fluxes. So that's what we're after. Now, because of the diversity that I mentioned earlier and the complexity of the problems we're dealing with, it would be nice if we had a common playing ground, also known as a sandbox. So I have a handful of memes over here. We start with the sandbox and then we take over the world. And no, the sand will not get inside your computer. So the plan is to create a joint global data set from the community and for the community to accelerate progress and knowledge and hopefully be positively impactful on science and society. Now, we're dealing with the proverbial 80-20 problem. It takes about 80% of someone's time to do data preparation or data pre-processing. And so it's the vast majority of the time is on preparing data, and then that leaves a smaller portion, about 20% for insight or for learning. And so there are a handful of references on that. The exact number is debated and debatable, but I think we can all agree on the fact that it takes a lot of time to do pre-processing of data and to set up your numerical experiment. And so if we tackle this as a community and we all have the same numerical experiment that we're playing with, it might help us move forward faster, which is the goal. So we have a 3-year project that I guess starts now. And the first half of those 3 years is the preparation of the data sets, going from the hydrographic networks to the in situ observations, the satellite observations with a variety of satellites, estimates of how much water goes from the land and underneath the land into the rivers, the runoff. Then we also have to think about how to link observations in real life from satellites and from in situ to the numerical description of hydrography of river networks. We need to discuss common metrics and hopefully write a paper that describes the experimental setup. So this is the outline for what we're hoping to accomplish in 18 months. There's a color code with a number of points of contact. Everybody is welcome to contribute. I want to make that very clear. We welcome and embrace everyone that's willing to help. We just need to have some executive power that, helps make decisions in a consensus base, but with some power for decision making as well. So that's the quick summary of what we're trying to do. And before we start putting data sets together and sharing, I think it's important for us all as a community to think about what's the right way to do this. And so I'd like to spend some time today talking about my hopes for how we might do it, and then welcome feedback from everyone on whether or not this resonates. Because putting data sets together takes a lot of effort, and naturally the people putting the effort into gathering those data sets deserve the positive feedback from that work, and so that's what we're hoping to encourage here. All right, so the headline is I'm hoping we'll make our data sets and if there is software, the software as well, openly accessible. with open licenses online. A good place for data is Zenodo. It's well proven. It's free. You get digital object identifiers, all that. It's you get versioning if you need. It's a very strong service for data sharing. I think GitHub has shown itself to be a go-to place for software. I think that should be the place where we go. Um, my hope is that we pick permissive, open licenses for consumption of the data and the software. My recommendation is Berkeley Software Distribution 3 clause for software and Creative Commons attribution for data. This can be debated, and as long as and we don't have to all pick the same licenses for what we do. My preference, I think, for the effort and to best serve the community is that we pick open licenses in general. If you prefer copyleft type licenses or non-commercial, that can be discussed, but I think there is value in engaging with everyone, including the commercial sector here. And then we together, I was a member of NASA, a representative for NASA Open Science when the program was running, formerly known as TOPS. We're on pause right now, but we spent a lot of time thinking about what are good community guidelines for data sharing. And I'll talk about a code of conduct, a code of scientific collaboration, and some governance. I want to acknowledge the positive impact of the software lifecycle improvement and modernization project, also known as SLIM. I've had a number of conversations with the leads of this effort that taught me a tremendous amount on community governance. There is a hot potato topic here, and that's institute data. I think we have to acknowledge that, people, countries, Met services put a lot of effort and resources into creating data sets. There is a pathway for public sharing in a global way, working together with the global run of data center. And so the data sets are out there, but it's not for us to redistribute. That's not the right thing to do. However, we can spend time handpicking the data, knowing what data, what specific stations, what specific timeline we'd like to deal with. We can write and share code that allows access to that data. And I think that's the right way for us to allow a common data set for everybody without breaking the rules. And we can engage perhaps Zimon at the end of this conversation today to make sure that this is a right path forward. But one thing is for sure is we're partnering with GRDC on this effort, and so we're going to do this right. Okay, so for community guidelines, there's a good thing to start with. It's called a code of conduct. It basically means be nice and respectful with everybody, and if you're not, you're out. All right, but there is a common code of conduct that has been very widely adopted in recent years. It's called the Contributor Covenant Code of Conduct. I think its latest version is 2.1. This is the snapshot that I have here, and it just means be nice with each other. And I suggest we should adopt this one or a similar type of code of conduct. We recently put some thought into what could be a code of conduct for scientific collaboration. I think in the case of a global community effort for putting data sets together and knowing the effort that goes into it, it's something that's really important for us to think about. And so I have 3 slides on this topic. I hope you can forgive me that we spent some time on this, but the vast majority of contributing members, at least those in the mailing list, and that might evolve, but a lot of us right now are research scientists or in academia or in government agencies, and our metrics of success are usually achieving scientific and societal impact, publishing articles in peer-reviewed journals, and gathering funding to support activities. This is usually what pays the bills for us. So it's good to put that up front for potential users. This is what pays the bills for us. What I propose that we commit to is access to cutting edge research software and data sets, openness of our methods and ideas, and opportunities for collaboration. But that also comes with some expectations. Basically means, hey, we're doing for free, be respectful. We're doing this for free, be respectful of our time and resources. By all means, if you can, collaborate with us. When we do what we do in an open manner is not to give secrets to others to like publish our ideas before us. It's to offer opportunities for collaboration rather than competition. I think it's an important thing to state. And then anything that potential users of the material, the digital tools that we put online, if they can in their own way, contribute to mutual success, citing the work, engage us in conversations for publications, perhaps proposals or presentations, and support us by contributing to our success metrics. I think it's a good thing for everybody. I suggest we have some collaborative roles in anybody that uses our stuff, quote unquote. Uh, Going from the independent users that just uses the data without interacting with us. In that case, let us know and cite us in your publications and presentations, and I think that's good enough. Now, if you need help with the dataset and you reach out to the dataset producers, then I think you become a supported users, and there is an expectation of being invited to join publications. Now, if that's yet to be determined, but if somebody thinks that the data sets we're putting together are so useful that they build an entire business model around it, whether academic or commercial, I think definitely cite, tell us that it's happening, and I think we should have a conversation about publications and proposals. And then there's the core team of people who produce the data and software, and they basically are expected to do everything, including contributing to proposals, to papers, and to the maintenance of the data set. So this is a proposal, and of course, as a community, we're all open to feedback on whether this resonates with you all. It's good practice to have some kind of governance in a big project such as this one, and so it's also good practice to have a governance matrix that aligns with the roles that I just mentioned in the code of collaboration. And so in this case, if we're going to be putting data sets online, everybody can access them. People who can make suggestions for changes, they're really contributors or data producers, committers in software lingo, project managers. But then if you want to support, a lot of people can. You can review also, and updates and decision, they're limited to the folks that are most actively involved. So basically, the contribution model that I'm describing here is one in which the people who do most of the work have the most influence, but we seek consensus as much as possible. And I think that would be adequate for what we're trying to do. So in short, what we're trying to accomplish, there are several topics that I mentioned in the earlier table with data sets to be produced. Every data set has a topical lead. I suggest that the topical leads are responsible for their data deliverables, expected to seek consensus, but have decision power. We have some candidate data sets that are good educated guesses in that table, and that also led to the invitations for the topical leads. Those are nothing but educated guesses. They can evolve, and if there are better data sets that come to fruition during the time of this river experiment, then we should absolutely embrace them. I'd like to suggest that the day that we have the community presentation for each of the topics should be considered as the proposal for the data set that the leads would like to suggest. And so that proposal is anticipated on the topic presentation day, and that we should hope for public sharing to happen within 2 months of that presentation, allowing some back and forth and some potential changes based on community feedback. As I said earlier, if anybody would like to help on a topic, please reach out to the topical leads, and in the group of co-leads for the river experiment, we already are meeting on a monthly basis. And what I suggest we do is that we invite the topical leads in the 3 months that precede their topic presentation to help kind of get ready for that proposal, that community proposal for what each data set ought to be. And these are the community meetings that I'm talking to you today about community open science practices, in addition to a small summary for public consumption of what the river experiment is about. In January, we'll talk about topography, morphology, and bathymetry. In April, we'll talk about in situ and satellite observations. We'll have a special session dedicated to SWOT observations in July. We'll talk about runoff production in October, and then the year after, a mapping between the model world and the observation world, and then hopefully wrap up the experimental design with common evaluation metrics. It's a cadence of every 3 months for 18 months. When I look at this, it feels like, a year and a half to get our act together might be long, but then I think to get community consensus, we need that time. And so that's how we build the timeline here. I'll conclude briefly. It's all about sustainability, fresh access, safe access to fresh water for drinking and sanitation for everyone. Uh, After 30 years of trying to run models, we now have help from incredible data, both on the in situ and the remote world. And the plan is to, put the basis for what could become an estimate of surface water everywhere, every time, including right now, merging the best of all worlds, numerical modeling, satellite observations, in situ observations, and hope that we can help support decision making for water resources management and water-related disasters mitigation. I think this is it. The affiliations for everybody who contributed to the RivEx article in the GWEX quarterly newsletter. Our community is now, I think, 70 strong. So there are a lot more people than what contributed to the initial paper. And I should probably update the affiliation based on the new membership. I'll stop here. Some pictures of the SWOT launch. And I thank you, everyone, for your attention. I'll exit this, maybe stop sharing and look at if there are hands or questions. Everybody's welcome to provide feedback, either on the experiment itself or the proposed community guidelines. I welcome your contribution. So maybe if you want to raise your hand or add a question in the chat, and then I'll call on people and allow. I think I need to allow you to talk before you can talk. So go ahead. The floor is everyone's. Augusto, I'm going to allow you to talk. Okay, you can unmute yourself and talk.
Yeah, thanks, Cedric. Thanks for the presentation. That was very comprehensive, and I really like the the last slides about conduct and like how people who want to join the group or want to use the data should approach the developers and the PIs of the data sets. But I think for us to, I don't know who's online and how many, but I think a start point would be like if you were to join the group. Like I don't know if everybody who's joining the meeting here are already participating, but what topic would you be the most would be the most relevant for you to contribute to? Like what topic of those, in terms of runoff fields or data sets or models, what would you be the where would contribute the most? I think that like if each person participating here could provide just like a one word, or if you can, Cedric, if you can share that the table again.
Yeah, let me do that.
the table with the models and the data sets and the observation.
Yeah. Oh, this one here?
Yeah. So like, yeah, just like if you asking people to provide what you, if you're going to join this group, what topic would be the most relevant to you, either for your work or the one that you feel the most comfortable with joining.
And how do you, I think this is a great suggestion, Augusto. I'm not quite sure how to do that. I think in a public setting such as this one, people might feel uncomfortable, with just like raising their hand and say, "Hey, I'm an expert in this. I'm gonna help." I want to say the bar is really low for contribution. If it's a topic of interest to you and that's something that perhaps you're already working on, your expertise is valuable and valued. And so I think we should be embracing of anyone who wants to help because there is a lot of work to be done here. And so if and also I think it's fair to suggest nobody's making promises over here. If there is something that is generally of interest and you'd like to put your name in the hat, you'll be invited, and based on your potential availability, you'll have an opportunity to volunteer for some subtasks or anything.
Yeah, my
Right?
suggestion was not to commit, to get any commitment, just to have an idea of who is here, who, what are the expertise that are joining us today. I mean, yeah, definitely. I said if you're going to join us, like if you're have the willingness, time, and yeah, what would be your main interest?
And so should we suggest people to like put what they're interested in the chat? Is that what you're thinking, Gusto?
Yeah, just as a starting point for a discussion.
Yeah, I think that's great. So I would like to invite Augusto, and I would like to invite everyone who is interested in one of these subtopics to, put the topic name in the chat, and that'll come with your name when you press enter.
The chat is disabled. I think the Q&A box.
Ooh, is chat disabled? In that case, we're gonna do Q&A. Oh, host. Oh yeah, you're right.
Can everyone see the Q&A box, or that's only with the host?
And oh, I see somebody. Oh, yeah. See, Simon, you just posted in the Q&A. Yes. So I guess people can hear us and people can post in the Q&A. So that's
But I can't see the Q&A. I mean, I can't see what people are writing, so I think only the hosts can
oh
see.
yeah. Thank you, Amin, for suggesting altimetry and SWOT and telling us that Q&A is visible, but the chat is disabled. Um, and hey, Simon, I hate to put you on the spot, but do you have any thoughts you'd be willing to share with the rest of the community on the hot potato topic, the elephant in the room that I suggested earlier? And maybe I can stop sharing and allow you to speak. Okay. If you want to share some thoughts, you're allowed to unmute yourself.
Oh, okay. Yeah. Hello, Cedric. Hello, all. I don't know how many people are in the chat actually or in the conference, but hello to everybody. So my name is Simon Michel. I'm the head of GRDC, and it's interesting to have such a overwhelming applause basically from Cedric for the work of GRDC. This is really which I would like to bring to my team as well, because for us it's sometimes the regular work of GRDC, and as I would say, GRDC is the starting place for further data sets behind, let's call it a GRDC core data set. So because as Cedric already said, we have a GRDC data set which can be shared we have to obey the wishes from the data providers regarding data licenses. So this is something we are also working together with WMO with a unified data policy to get more and more towards a really open data set. But sometimes countries provide a data license, which is most of the time Creative Commons open licenses, something like that. But some prohibit commercial use and stuff like that. So this is something we need to talk about in more detail. The interesting thing for us as GRDC, because we are also learning and moving on the path towards more and better services for ourselves, is the versioning. Because at the moment we don't have any versioning installed for the data sets of GRDC. We're just providing new data, new data, new data. So to be able to reproduce any results which will result from the RivEx project, it would be really great to have some sort of a versioning and an update of an existing data set and stuff like that. This is for me quite interesting, because we as GRDC have a data portal where a lot of data is available to the user, but I think it's important to have such a version which can be called in situ RivEx 1.0 or something like that, and then we have 2.0 and so on and so on. What's also for me as GRDC interesting, because Augusto talked about runoff fields. I don't know if I'm getting it right. I'm not so familiar with models at the moment, but we have a river, or how to call it, a composite runoff field in GRDC, and this is something which is quite an old data set. So we are also interested in updating such a data set, but this can, from GRDC sides, only done with collaboration with other scientists and partners, basically. And this is also why I'm here. So I hope not only to give data, but to receive also important insights, important knowledge, and new, let's say, products which can be provided by GRDC to the community. And this is one of the main roles which I see GRDC in this project, that we provide, at least besides the core data set, platform where the scientific community can start to look where are more projects or more data sets included in the RivEx project, basically. So these are my my thoughts at the moment, and I'm very happy to be part of this project and happy to collaborate with all of you.
Thank you so much, Simon, for your words here and your feedback. I was going through the list of participants. So we have about nearly 20 people here. I attempted to promote a couple of people who are co-leads into being oh, see, Guy, can I allow you to? I think you can allow yourself to talk, Guy, if you want to say.
Yes, I can.
People.
If you allow me to talk, I can. But if I talk too much, please tell me.
Go ahead. Guy Schumann is one of the co-lead.
Yeah. So hi everyone. It's really strange because the only person I now see is Cedric. So I don't see anybody else. So, but thanks very much for joining. And I am indeed the co-lead of this RivEx experiment. And it is a pleasure to be here because I think this is a crucial topic. And I'm very glad JRDC already took the mic, because I do indeed think that data sets like these are crucial. They're not without problems. Everybody knows that, but it's the same with all we do in this, right? Many models, many things like databases from gauge data like JRDC, others as well. A lot of rain data is absolutely fantastic that we need to drive models. And when I was still at JPL with Cedric, actually, we're all working on this SWAP mission, right? This wonderful stuff that actually then got launched, and it's actually working, I dare say. But without all these models, without all these data sets that Cedric presented here, I do think it's not wrong to say that the French and NASA would have had problems passing the missions through the final phase and getting it up there. So we very often as scientists, we underestimate the impact of these global models and the value of those things that it can have for actually getting a billion-dollar mission into space for hydrology. Ocean always had their big thing. They were always doing great. They were always having, you know, this is what we can resolve with SWOT, blah, blah. Hydrology had a much harder time getting this through. And it was only through the modeling globally, flood modeling, hydrology modeling, that we were able to show what happens when you start assimilating stuff into models that eventually comes from something like SWOT. See, now I'm already talking too much. But I just want to highlight this RivEx, the sandbox Cedric is presenting, and this is really his big idea, I guess, and some of us as well contribute, but it's really, he's been going on about this for a long time. It's really needed, and we need more of you to contribute. I mean, thanks very much for Simon to say, you know, he's in the project. I think we need many more, because as I understand it, this is a big effort, but it's also for many of us a completely volunteering effort. You know, and we need more people. It just takes people to do this kind of thing. So thanks a lot. And my background, by the way, is I'm very EO flood person. So anything more hydrology, SWOT, probably Cedric, and there are a lot of other people, Augusto, if you're online, maybe I don't, we're working with a lot of other co-leads as well. Maybe they can say a few words, but any questions you have, just send it to us. Happy to answer. Thank you.
Thanks so much, Guy. I want to acknowledge Ganesh, who volunteered on topic 1, and thank you, Ganesh. And also, I see you have a question about, is the goal to collaborate on observation data sets or the vision to provide relevant benchmarking data sets across scales? I would tend to suggest it's the latter. We don't just want to do a sandbox, but we'd like to build a sandbox that can be used for modeling, and then use that to compare models and their outputs and learn. And I believe we might have from local to global in the title of the RivEx quarterly newsletter article that we published. We'd like to go across scales, but I think it's important. We want to be applicable at regional and local scale, but it has to be global. And so I think that's the answer to your question. And you know what? I'm going to allow you to talk in case you wanted to ask a follow-up. And, oh, was that good?
Yeah. That answer.
Okay, well, thanks for your interest. I also want to highlight we have Perong Lin on the call here. She's one of the co-leads. I invited you to be a panelist. I know it's probably very early or very late over there, so if you don't want to talk or say anything, that's totally fine. We're so glad to have you here on board with us. And I want to shout out to Yuan Yang, who recently volunteered to help with the runoff production. And Yuan has been doing a lot of great work on a variety of subsequent data sets, grades, GFRC, was that what it was called? And then more recently, HydroDL. And so thank you, Yuan, for being here. Any other questions in the Q&A or anywhere from anyone? Augusto, you still have your hand up, but I don't know if it's an old hand or a new hand.
It's an old hand.
Okay.
Yeah, I'd like to just a remark on Simon's comment on updating the runoff product. I think that there'll be a good outcome from RivEx to, join efforts, not only like take JRDC's data, but also contribute back with, if you end up generating, some sort of best of our knowledge runoff field that it could be used by JRDC and then others.
Absolutely. Thanks, Augusto. Any other thoughts or questions before we declare victory for today? Oh, thanks, Perong. I see you'll know it's midnight over there. We'll be quiet. I appreciate you joining us so late. Apologies for the world being so big and the difficulty of finding time that works with everyone. And next time you will get to decide what time you can speak. And if I have to get up at 12, I'll do that. Yes, absolutely. Contact information for the team needs. I think the easiest thing you can do, Berina, is email contacts@gwex.org, or email me, and or Augusto or Simon. But the easiest, maybe I'll just put it in the chat. Answer live. Oh, I can type my answer. I'll do contact@gwex.org, and that'll put you in touch with the GWEX leadership can help you track us down. And what else? If you'd like to be involved in or included in the mailing list, we're still working on that, but we have RivEx members, RivEx-members, JPL NASA Gov, and I can include anyone who's interested in participating. Any other question that I've missed? I think that's good. In that case, let's thank everyone for joining. I appreciate your time. Oh, you know what? I've always wanted to say this: like and subscribe, okay? Because we're gonna post this on YouTube, and so you click the bell button and all that, and you get updated on the GWEX content. Thanks everyone for joining. Thanks to all the co-leads for this activity and everybody who contributed thus far or will contribute in the future. And I look forward to the next talk in January, and that should be Perong and Dai. Thanks everyone. Enjoy the rest of your day or the rest of your night.
Thanks, Cedric. Thanks, everyone.
Bye.
Thank you.
Yeah.
Bye.
Thank you. Bye. Bye.